So this is going to be our group discussion problem review. Hopefully this will be a little bit more like what we would do in the classroom. Question number 1 is 2.76. If we're looking at your textbook, it asks how many significant digits. It had one significant digit, had an uncertainty of plus or minus 1/1000th. Part B, it had two significant digits, had an uncertainty of, there's thousands, 100,000ths. Part C had three significant digits, had an uncertainty of plus or minus 1. Letter D had four significant digits because it was 0.002600. So as we start, the 2 is significant. Everything after that is also significant. And the uncertainty is plus or minus 0.001 times 10 to the negative 3, or 1 times 10 to the negative 6. You could have done that as well. Letter E is two significant digits. Uncertainty is plus or minus 0.1 times 10 to the 6th. So right here, this one right here, so that would be your 100,000ths. So that is your uncertainty is plus or minus 1/100,000th. All right, or 0.1 millionth. All right, a little confusing there. Hopefully you get that. So we're going to do a little something different. Whenever we do this ed puzzle, if you got all of these right, 1 point, 1 point, 1 point, 1 point, 1 point, we're going to make this worth 5 points. So tell me how many points you got on this. Number 2, A is 4.60 centimeters. B should not be 4.000 meters. It should be 4 meters squared. And the reason is one of those parts only had one significant digits, okay? Or significant figures. And then here we have 10,010 joules. And then letter D is 10, just 10, because we divided millimeters by millimeters, so there are no units. So again, if you got these right, here's 1, 2, 3, 4 points, 1 point each. So we'll do that. Number 3. (32 degrees Fahrenheit, 0 degrees Celsius, 273.15 Kelvin. If you just add 273 Kelvin, that is fine. Over here to the side, you definitely need to know between Kelvin and degrees Celsius. Notice I don't say degree Kelvin, it is only Kelvin. It is degrees Celsius and degrees Fahrenheit, but Kelvin was developed based on the properties of the universe, where we can't get anything colder than 0 Kelvin. That's the absolute minimum. As a matter of fact, we'll talk a little bit about fuzzy matter or the Bose-Einstein condensates whenever we get back to school maybe. But so each increase in Kelvin is equal to the magnitude of an increase in degrees Celsius. So if you increase 273 Kelvin, you also increase 273 degrees Celsius. If you go up 100 Kelvin, you go up 100 degrees Celsius. So that makes it easy. Fahrenheit was not based on the properties of water or on the, which like degrees Celsius was. It was based on, I believe, you can look up the history of this, I may be wrong, one of the properties of like an alcohol, which was 0. And that was the coldest thing that Fahrenheit could get as a freezing point. So that's what he made his units based on. So that's, but on water, it's 32 to 212 degrees Fahrenheit from freezing to boiling. So there's 180 degrees in there. And so that's, we won't use Fahrenheit very much at all. We try to stay away from that in high school chemistry, okay? Obviously you'll have to be able to convert back and forth in the real world on that. So we'll be careful with that later on, okay? Number 4. 2 centimeters times 2.0 times 2.0 times 2.0. 2 significant digits, 2 significant digits, 2 significant digits, and our answer is going to be 2 significant digits. Make sure you had cubic centimeters, okay? So that's worth 1 point. So here we have 5.01 grams per milliliters for pyrite, or the iron 2 sulfide. Gold, solid gold, is 9.3 grams per milliliter, and mercury is 13.6 grams per milliliter. Now, to ask how would you separate the pyrite from the gold? That's kind of like saying how would you separate sand from wood, as long as you had some liquid water somewhere. If this is solid, this is solid, and the mercury is liquid, well, you could drop the gold into the liquid mercury and it would possibly sink, correct? While the iron pyrite would still float, and you could just scoop that off the top here. And so, assuming there would be no reaction or amalgamation, this is not part of your grade, okay? But then the gold solid and the pyrite solids could both be placed into liquid mercury, and the only gold would sink into the bottom while the pyrite would float. So I would ask, if you're curious, look up what amalgams are and amalgamation, and there's some really neat videos out there on YouTube and stuff where mercury actually just absorbs the gold. And so if that would happen, to get that gold back out, you would have to do something to it. So there's a lot of stuff going on. They still use the mercury in other undeveloped countries where there is no, let me get the ICP stuff out of the way, where there's no EPA. This one is number 6. So if we have 0.200 kilograms, which is 200 milliliters or 200 grams of water, if we burn 2.50 grams of wood, and the temperature of the water went from 22.1 degrees Celsius to 28.7 degrees Celsius, that means there's a change, the delta in math means change in temperature, of 6.6 degrees Celsius. So this 200 milliliters of water went up a total of 6.6 degrees Celsius. So if we're looking at this, we know that the specific heat, that's the C, is the specific heat of water, liquid water, is 4.184 joules of energy for every gram that changes 1 degree Celsius. There's this formula that the overall change or movement of heat into or out of an object is equal to the specific heat of that material, with these units, joules per gram degree Celsius, times the mass, which is going to be in grams. So we're going to change this kilograms into grams anyway, times the temperature in degrees Celsius. So that's going to cancel the grams, cancel the degrees Celsius, only end up with the joules. So in this case, if we know the specific heat of water, 4.184 joules per gram degree Celsius, times 200 grams of water, times 6.6 degrees Celsius, notice the grams cancel and the degrees Celsius cancel, we're going to end up with 5,522 joules, or 5,500 joules in 2.50 grams of wood, meaning that the energy content of the wood is about 5,500 joules of energy per 250 grams of wood, so we'll do the math there. And so we should end up with about 2,200 joules per gram of wood. Okay, joules of energy per gram of wood. So if you got to there, give yourself a point. Going on up, number 7, which is 1.40, A through H. We're just looking for these answers. I'll show you how I got there. So 2.37 times 10 to the 5 milliliters, 800,000 grams, or 8 times 10 to the 5 grams, 0.000592 millimeters, or 5.92 times 10 to the negative 4 meters. I think that should be 1, 2. Sorry. Meters. 0.00831 kilograms, or 8.31 times 10 to the negative 3 kilograms. Letter E. 9.62 microliters. 800 meters into kilometers is 8 kilometers. G is 0.0193 grams, or 1.93 times 10 to the negative 2 grams. Let me see. So 0.0000345 liters, or 3.45 times 10 to the negative 6 liters. And I think on my video I said you wouldn't need to know deciliters. So yeah, you definitely need to know that. So on the test, you need to know liters to deciliters, or deciliters back to liters, or decimeters to liters. So know that conversion as well. So these are things you should be able to do. You should know these just from memory for the test. Number 8, we have 23 changing from degrees Celsius going to Kelvin. Okay, Kelvin to degrees Celsius, you just subtract the 273. If you're going from degrees Celsius to Kelvin, you add the 273. Okay, so that's 100 degrees Fahrenheit, or 311 Kelvin. All right. Number 9. So these are the two conversions that are equal to one another. These are the two ways we would use those. We could use these as well. Okay, grams to kilograms. 3 feet to a yard, or 1 yard to 3 feet. 100 centimeters is equal to 1 meter, or 1 meter is equal to 100 centimeters. Okay. 0.01 meters is equal to 1 centimeter, or 1 centimeter is equal to 0.01 meters. All right. Number 10. 70 miles an hour. If we know that 1 mile is equal to 1.61 kilometers, we end up with 112.7 kilometers per hour. So we're assuming how many significant digits? This would only be 100 kilometers per hour. So if we put a decimal there, it'd change that, wouldn't it? So we're not worried about significant digits on that one. Okay, 4 significant digits, 2 significant digits, we're going to kind of go on out there, but 0.0313, if you had 0.032, that would be wrong. 0.031, you're good, kilometers per second. So again, the conversions here, these are things we expect you to know how to do. These are some examples. So part C, seconds, you get rid of the seconds here. You could have done that last. Change that to hours, and then we this is meters per hour. Okay, and so we end up with 112,700 meters per hour. And then letter D, get rid of the kilometers and turn it into meters. So we have 31.3 meters per second. There's number 10. So there it is, and hopefully this works out for us.